first topic of the last third of the class, following the same pattern as before. On Wednesday we'll review the second exam, but today we press on to talk about arrays. So arrays are data types of variable size. They're crucial for doing almost any kind of software development because they allow you to represent data in groups of larger than one. Right now you don't have a way of doing that, and so you don't have a way of actually operating on a lot of data. And that limits the reason why you'd ever use a computer. Because you have computers so that they can do calculations for you, and if they can only do 1, 2, or 3 calculations, then you can probably do that by hand faster than you can write the code. So the reason why we have variables is so that we abstractly have a way of storing a large amount of data with just a few names so that we can refer to them. So the things that we've seen so far have been variables with types. And these are all have been variables that hold a single thing. And today we're going to add something to that understanding. We're going to have variables that hold more than a single thing. Okay, so before I describe the syntax for using arrays, I'm going to describe for you or explain to you why we should have many variables. And I think abstractly, when you first hear about arrays, it's sort of like, why would I want to have these things? It just seems like an extra complication to programming languages, right? So the reason why we have this, as I was trying to explain before, is because of automation. When I want to do tasks that a computer can do for me, I want to have enough work for the computer to do that the computer spends real time on it, that I don't have the computer do things that took me longer to code than I could have just done myself with pen and paper or whatever I was going to do. So there's this problem when you want to refer to a lot of data, and that problem has to do with how I name that data. So if you want to have code that operates on people's names or something, like remembers people's names for logging into an email system, you can have a number of variables. We all know that we can define variables, like name 1, name 2, name 3. But I don't have a way of referring to these in automation. I can't write a loop where for I equals 0, I less than 3, I plus plus, I can iterate over name 1, name 2, and name 3. So I can't operate on large numbers of variables. My language does not explain how I can do that, or doesn't give me the functionality to be able to do that. So for example, if I wanted to write, say, I don't know, freshman after everybody's first name in this list, I would want to have something where it was like, take the person's name and say plus space freshman inside this loop. So it would be Sally plus freshman, and Aaron plus freshman, and Melissa plus freshman. But I can't do that because there's nothing that I can write that would allow me to have the inside of the loop refer to one of these variables and have the next iteration of I refer to the second variable and the third variable and so on. I don't have a syntax that allows me to describe how to do this, so the computer can't do it for me. So arrays are going to allow you to do that. What an array is a list of entries that have the same type. It's simply going to be a name for a list, where everything in that list is the same type. You can refer to any position in that list with a number. The list can be arbitrarily long, given the limits of the hardware of your machine and some software aspects of your operating system. And that allows you to handle a tremendous amount of data at once, as long as you use loops to do it. So what we're going to see today is the very basics of arrays. So every time I show you a new kind of syntax, I show you how to use it in specific steps. And the steps for arrays are first that you declare the array. and then you allocate space for the array, and then finally you access or initialize individual members of the array. And this is very similar to a variable, except that we have that additional step. So with the variable, we declare the variable, and then we initialize the variable before we can use data from that variable, right? If I have int x, then I need to assign x equal to 4 or something in order to have data in that variable x before I can use x to do anything. The same thing is true for arrays, except that there's this additional step here where we allocate space for the array. And that's because an array can have arbitrary length. So we need to tell Java how much memory to set aside for this array so that Java can be ready for the way that we use the array. If we don't tell Java how much memory to set aside, then there can be problems. There are programming languages that will dynamically allocate more space for you, and that's kind of a service that those languages provide. But Java, being a little old school, expects you to say how much space you need. Okay. So step one, we need to declare an array. So let's suppose that we wanted to track lots of student IDs, and we knew we had a constant for the number of students that there are. So let's say that the constant num students is equal to 5,000, and we want to declare an array of integers to track all their student IDs. The way that we declare this array of integers will be with int and the square brackets student IDs. So those two square brackets, open square bracket, close square bracket, indicates that we don't simply have a single integer variable, we have an array of integers. And it's a very important piece of notation because that distinguishes it from a regular integer declaration like int stuff here. So once you declare this variable student IDs as an array of integers, Java expects you to treat it a little bit differently. It's going to expect you to allocate memory for it. So let's keep that separate from what declaration does. So declaration simply creates in memory a name for what will be a place in memory that holds a list of student IDs. But right now, we don't even know how long that list is. There's nothing stored in this array. Java hasn't been asked to create memory space for this array. So all we have is an identifier. We just have a name for what will be a variable. So this is a little bit different from variables that you've used in the past. In the past, once you declared an integer, or once you declared a string, there was space in memory for your string, because you were storing exactly one integer, or exactly one string. But now, because you've declared an array, Java isn't yet able to allow you to put stuff into that array because it doesn't know how much space you need for this array. That's why we need to allocate the array section. So allocation is essential because non-array variables contain only one value. So because they contain only one value, Java knows how big that value is. It's easy to have Java automatically allocate you space for one integer. But when you have an array, it needs to know the size of that list of data in order to set aside memory for you. So when I allocate that space for student IDs, I'll say student IDs equals new int num students. This is a very special new notation that we're seeing. So this is assigning the identifier student IDs to a block of memory. A new block. So the word new is a special operator. And you'll see it only in the context where we want Java to save memory for you. Right now, you're seeing it in the context where we're allocating memory for an array. And in CSE 17, you'll see it as allocating memory for objects as well. So anytime you want to allocate memory, set aside memory in your RAM to hold something that the program is going to do, use the operator new. And then after that new, you have a space, and then in order to find out what is exactly going to be allocated, it's an integer array of size num students. So that's written type square brackets size square brackets. Now it's important to have type square bracket size square bracket because Java is actually going to set aside some space in your memory, some number of kilobytes, some number of megabytes, some number of gigabytes. And in order to set aside that space, it has to know exactly what it's storing. So when it's storing integers or strings or whatever, integers and strings and doubles are all different sizes. So it has to decide, okay, in my memory, I want to have 14.5 kilobytes or something. So in order to figure out that number of kilobytes should be, Java needs to know the type and how many there will be. So integers in a 64-bit operating system typically have 32 bits, and this will be 32 bits times the number of students, which will be, a certain size. And so that's how Java actually figures out the amount of RAM to set aside for your specific variable.
In the first line, what does the final is do as to normal is?
What does the word final do? I'm sorry that I didn't introduce it before. Final is a special flag that you can assign when you initialize a variable, making this constant. So final makes this variable unchangeable after it's been assigned. So why would I want to have something like this? Why would I want to have a variable that I can't change later? So the reason why I have this, the reason why final exists, is when you're working with other programmers. And you're working with other programmers to calculate something or to do some sort of software that relies on constants. So maybe the number of students is constant, or the value of pi is constant. You need to frequently agree with other programmers what the value of certain constants will be. But when you code with other programmers, sometimes other people are sloppy. They write their code in all sorts of different ways, or maybe they were drunk and coded a bug, or all sorts of problems, right? So if somebody went and wrote num students plus plus, right, in their code, then who's to know that they haven't changed the constant on it? And that would be a huge headache, because then you'd have to make sure your code worked, you'd have to police everybody else's code to make sure their code worked also. So that'd be a huge waste of your time and everybody else's. So in order to have variables that remain constant and never change, so that everybody can rely on the same data, we can declare that variable final. And when that variable is declared final, after it's been initialized by assigning a value to it, it cannot change anymore, and that makes it so that everybody can work with the same data. Good question. Yeah.
So if you used final on it and then later in the code you tried to modify it, would it be a compiler error?
That's right. So if you use final on a variable and you later tried to assign another value to it, then it would give you a compiler error. It would say assignment to final variable. Okay. So this is how we break down the allocation statement, and you can compress it with a declaration statement for an array of integers. So first we have the array type, then we have a square bracket, pair of square brackets, with the array name, and this together declares that I have an array of integers. I will assign that array of integers a space in memory that I want to allocate for that array. So when I do that, I need to use the operator new, and I need to say what type it is and how much space I want to allocate. So new int 25. So if I wanted to make an array of 25 integers, I would write exactly this. If I had some variable or some final variable that was going to decide how much memory I need to store, then that would be a variable name in here. Or it could be, some arithmetic calculation of one variable plus another variable, or something like that. You could take input from the user, and that could be the integer that the user typed in. Regardless, inside the square brackets, it must evaluate to an integer, because the Java needs an integer in order to decide exactly how many ints it will store in your array. So what this creates, after you've declared your your array variable is a space in memory that you can think of as a list that the array variable points to. So when I say list 1, that refers to the entire list. It's an identifier for the entire list. And when I refer to members of list 1, members of that array, then I will say list 1 bracket 0 bracket. The shortening for that is list 1 sub 0. So the first array member of the array list 1 will be called list 1 sub 0. The second one will be list 1 sub 1, the third one will be list 1 sub 2, and so on up to list 1 sub 24. Now, if I attempt to use list 1 sub 25 or list 1 sub 100, I'll get a compiler error, or I'll get a runtime error, depending on how it comes up. Both of those cases will result in you doing something called walking off the end of an array. When you try to use a member of an array which doesn't exist because the array is shorter than the member that you're referring to, then you get a runtime error, or a compiler error if it's a constant. Okay, so what does allocation do? Allocation, remember the previous picture that we had here. The picture that we had was just student IDs, this pointer pointing to nothing. Now we've allocated the memory for student IDs. Now we have this list of integer variables that is the meat of the array, that is actually space available for me to store 25 integers, or 5,000 integers for num students. So once I've allocated this space, I now have 5,000 new integers that have not been assigned. When I create a single integer variable, right, I can't use it until I store a value into that integer variable. The same thing is true for all of these variables, except now I have 5,000 of them because num students is 5,000. So each one of these variables hasn't been assigned. It's just an empty integer. So my final step is to initialize the data in this array by putting values into that array. So if we want to actually use what's in this array, we have to fill it up with data. And I have a number of ways to fill that up with data. I can fill it up explicitly just by making assignments. Like for example, if I have some string student IDs that holds people's names or something, maybe it holds 10 strings, I can explicitly assign every member of that array by saying student ID sub 0 equals Allison, student IDs 1 is equal to Becky, student IDs 2 is equal to Charlie, and so on, until I've used up all 10 members of that array. Now that's a little bit tedious and it makes your code rather long, and more importantly, it's not allowing you to do anything faster than the computer, because now you're taking time to write things explicitly in the code that you want to have the computer to do, and it's now taking you a lot longer to write the code than it is having the computer to run the code. But you could make it explicit. Like sometimes when we have array constants that have some members that are just always going to be the same, we literally fill out the array in this manner because the array is a constant and we need to have it filled out with all the members. No matter how you initialize those variables though, you have to initialize everything using these square brackets. So student ID sub 0 assigned to 30,293 only assigns this member of the array. Student ID sub 1 assigned to 30,523 only assigns this member of the array. It doesn't assign anything else, and there's no way for you to assign a range. So I can't say student IDs 0 to 5 all equal to this. I can only say a specific member and assign it to a specific value. Also, because these are individual strings or individual integers, the type that you assign to each one of these members has to match the type of the array. So if you had an array of integers, each one of the members of that array is an integer, and you have to store an integer into that array member. Otherwise, you get a compiler error. So the types have to match, or they have to at least be implicitly castable. So the reason why we have arrays, of course, is not so that we can do things in a tedious way. It's so that we can have the computer do things faster for us. So one way that I can initialize the array faster is to create a loop where initialization of the array is handled inside the loop. So here's an example. I can declare my num students variable. Then I can declare the student IDs and allocate value for it. And then I can use a loop for I equal to 0, I less than num students. I can assign each one of the student IDs to I, meaning that the first student ID sub 0, is equal to 0. Student ID sub 1 is equal to 1. Student ID sub 2 is equal to 2, and so on and so on and so on. So that means that the first student ID is 0, the second student ID is 1, the third student ID is 2. And without having to insert an explicit statement that assigns the value in each integer, I have now created a loop which assigns them all in order so that I didn't have to do that. Here's where you can see that things are kind of speeding up. Now, whereas before I had to write code that would handle each member of that array, now I've got a loop that handles it all for me. Now I don't have to write 5,293 lines of code in order to handle every student ID. Of course, there are some design constraints to this. This loop that I have here is just assigning people student IDs in order, and maybe you don't want to assign people consecutive student IDs for some reason. Nobody wants to be first, nobody wants to be last. So maybe that's an issue, but at least we have a way of automatically assigning student IDs to everybody. If we want to be more clever with the way that we assign student ID, maybe we don't do it with just incremental values, maybe we do it with random values. Or maybe we do it with incremental values that are modified with random values so that we can always get something that's moving upwards or something like that. Okay, so it's crucial to understand how exactly these square brackets work. You use empty square brackets when you're declaring a new array. Otherwise, when you're allocating that array, you need to specify the size of that array. And when you're accessing members of that array, you're providing integers that indicate which member of the array you want access. So for example, in computer gaming, we frequently have models of characters like, I don't know, Ken and Ryu. You know, they're going to do their uppercut. And Ken and Ryu have thousands and thousands of triangles that actually model the character on the screen. Those triangles are described by points in space, points in 3 dimensions. And in particular, it's 3 points in 3 dimensions for each triangle, right? So a point in 3 dimensions is represented in the code as usually 3 members of an array. So if I had, this is an oversimplification, but I could have like double bracket Ken model equals new double 3-star 1,000, then that would allocate 1,000 points in space for my Ken model, where every triplet would represent XYZ for the first point, XYZ for the second point, XYZ for the third point, and so on and so on. So the reason why I have these arrays is that I can organize them into all sorts of ways. Like I don't have to use them simply as a list, but I can treat them as a list of triplets. So this allocation here, student IDs 3-star I plus 0, is something that you'll see frequently in graphics programming, where maybe it's not student IDs, but it's like Ken model. And 3-star I plus 0, 3-star describes an X coordinate, 3-star I plus 1 describes a Y coordinate, 3-star I plus 2 describes a Z coordinate, and then incrementing I just moves me over to the next point in space. So if I is equal to 0, this whole thing is, and this is plus 0, then this whole thing is equal to 0. And as I move I over, it starts with 0, and then it's 3, and then it's 6, and then it's 9. And that describes for me triplets in that array that describe XYZ coordinates. I don't have to do that with triplets. I could do this with quadruplets if I wanted to, or I could have any arbitrary mathematical expression that provides an integer at the end to reference a member in this array. And it could be the case that this expression is pretty complicated, but it's essential for the programmer to make sure that no matter what happens, this expression never produces a value that's larger than the size of the array. If you refer to a member of an array that is larger than the size of the array, or if you refer to a member of the array that has not been initialized yet, then you'll get a runtime error. So that could be a problem. Yes?
What is this 3 star I plus 1 doing in this case exactly? Like, it seems like it's just making the next index the value at the previous index.
You mean, why am I storing 3 star I plus 1?
Yeah, that means.
It's just a mathematical expression that I'm storing there. It doesn't have to mean anything. In this case, it's just me cutting and pasting, to be honest. Because in this example here, student IDs is an integer, so I just add integers. I guess it's also sort of showing that because it's an integer, whatever's on the right of the assignment operator is also an integer. Okay, so here are the 3 steps. Declaration gives me simply a name to refer to a list of variables. It does not create the list of variables. It only gives me the name. Allocation allocates space in memory for that list of variables. So that's what actually creates the list of variables. After allocation, I have individual integers or strings or whatever this is for every member of up to the size of the array. Then finally, after I've initialized and accessed these variables, I can use these variables as if they're all independent variables. So you cannot use any member of an array before it's been initialized. Okay, so Java is an easy-to-use language. I realize that where you guys are right now, it may not seem like the easiest-to-use language. You'll have an opportunity in the future to see languages that are really hard to use, and you'll look back at Java and think, hey, Java wasn't so bad. You could go and Google Haskell to find out about languages that are hard to use. But one nice feature of Java is that it tells you the length of an array. So using the Java function .length, or I guess the type variable .length, you can find out how many members there are to an array. So this is convenient because I could have a method that takes an array as input, and I wouldn't even know how long that array is, how many members are in that array. But the first thing I could do is I could say in size equals input.length, and that would tell me how many members are in that array. So I can take arrays as input, and I can figure out their size and work with them because I know how long they are. If you don't know how long an array is, then you can walk off the end of the array really easily, right? Because if you don't know how long the array is, then what's to say that even the first member of the array is off the end of the array, or that it's even been allocated? So this is an important point. It's really useful to use the .length operator in order to find out how long any given array is. Okay, so wow, that was a super short lecture. Does anybody have any questions on arrays? I think I'll try to cover some more material in the next lecture. Okay. Okay, so let's see some things that we can do with arrays. One of the things that we can do is we can perform a search. So search is a foundation of computer science. It's something that you guys are familiar with just because you're used to Google search or Bing search or whatever. But search is actually much more involved in all sorts of things. And one of the simplest things that you can do is a linear search using an array. So if I had an array of ints called grades, if I wanted to find the lowest grade and print its index, in other words, tell me which member of the array actually had the lowest grade, then what I could do is I could say int index equals 0, int min is equal to grade sub 0, and then for int I equal to 1, I less than grades at length I plus plus. In other words, iterating over the members of grades, starting with the second member. If grade sub I is less than min, which starts off as the first member of grades but could be updated later. If the member of grades that I'm looking at is smaller than the min, update the min to be equal to the current member of grades and update index to be equal to I. And then iterate doing this over and over again over the for loop until I'm done. So what happens is, as I look at each member of grades, if I see a member of grades, grade sub I, which happens to be smaller than the minimum that I've seen so far, make the minimum equal to that member of grades, and update the index equal to I. So at the end, if I started off with grade sub 0 and grade sub 0 was the smallest member of grades, then at no point would I hit this if statement, because since grades is the smallest, there would be no member of grades which is smaller than the min. So I would never change what min is, and I would never change what the index was. So it would correctly return index equal to 0, and the min equals grade sub 0 if grade sub 0 was the smallest. But if grade sub 0 wasn't the smallest, meaning that there was some member of grades that had a value smaller than the grade sub 0, then what would happen in this for loop would be that I would iterate through this for loop, and eventually for some I equal to some value, that grade sub I would have a value less than the min, because grade sub 0 is not the smallest. So therefore, we'd assign min equal to that smallest value, that new smallest value, and we'd remember the index equal to I. And at the end of that loop, it would tell us the smallest was equal to min, and that the index was at I. So you can see that no matter what the arrangement of the values in that array, this code effectively searches that array for the smallest value inside grades, and tells us which member it is inside grades by telling us the index of that member. Another thing I can do with an array is I could shuffle the contents of an array. So I can take an array and I can randomly swap each member of the array so that it's thoroughly shuffled. How can I do that? So what I can do is I can have a for loop. You'll see that for loops happen a lot with arrays because for loops operate with an iterator and have a tendency to operate less than the length of the array. So this is the compatibility between for loops and arrays is probably one of the big reasons why for loops are the most popular loop. So here we've got int running from 0 to int I equal to 0, I less than int array.length. We start with looking for a random number, a random member to swap with. So here we'll find int target, and we'll assign it into int array.length times math.random. So here math.random is some value from 0 to 1, not including 1, but including 0. So multiplying it by int array.length gives us some integer, when we cast it to an integer, that has value between 0 and int array.length minus 1. So target is some random number between 0 and int array.length minus 1, which is nice because that refers to the index of a randomly selected array member. So then what I can do is I can swap the values of target with the ith member. So I can say int temp is equal to int array target is equal to int array sub I is equal to temp. So that basically says, take that target value stored in temp, take my I value stored in target, take temp stored into my I value. So I basically swap the two values. And what this loop does over the many times that we run it is that it takes each member in the position that it exists in, finds some other random member, and swaps it. So that means that every single member in this array has been moved randomly, or it was selected to be randomly swapped with itself, which is also sort of moving randomly. So this is a cool way where you can take the contents of an array. Maybe they represent cards in a deck. Maybe they represent, I don't know, suggested friends on Facebook, and you want to shuffle that array so that your user on Facebook doesn't think you're always suggesting the same friends. You can always shuffle things in order to put things in a different order without losing anything. So note that this swapping procedure never loses any information. We always take two members of an array and switch them, but at no point can we ever lose data in this array because we just swap pairs. And even if the pairs get shuffled quite a bit, even if we randomly select the same member to be moved several times, we never lose data in this array because we always just change values. Another thing that you should be aware of is how exactly we copy arrays. So far, you've seen variables, and single variables can be copied very easily by declaring a new variable and storing the value of the old variable into the new variable. But if you want to copy an array, you've got a slightly different problem. And that's because the identifier that you have for the array is only a pointer. It only points to the place in memory where you have that array. And this concept, it nails people on exams over and over again, and it actually creates many, many bugs in software. So I want everybody to be really aware of this. So if I write this code like this, like int array list1 is equal to new int elements, and then int array list2 is equal to list1, then what this is going to do is it's going to create a new integer array identifier called list2. Remember, this is the declaration phase. And it's going to say, well, that's equal to list1. That's not going to allocate new memory for list2. We didn't use the new operator, so it didn't allocate new memory. All that's happening here is that list2 points to the same place in memory that list1 points to. So this would be a problem, right? Like I could make a copy of a regular variable this way, right? If I had int val1 and int val2, and I said val2 is equal to val1, then I've got two variables where they both have the same value. And modifying val2 would not change val1 because it's two copies of the same data, right? But when list2 points to the same place in memory as list1, then changes to list1 become apparent when you change list2. So for example, if list1 had 5 members here, and I ran all this code, so imagine that I allocated list1, and in fact imagine that I assigned values to all of these members here, and then I declared list2 and had it point to list1, then if the value of the third member of list1 is 5, right? If list1 sub 2 is 5, then list2 sub 1 is also 5, because it points to the same memory. But if I change the value of list1 sub 2 to 10, right? Because they point to the same memory, then that change also happens when you refer to list2. And that blows people's minds because it seems like that's not like how it should work. So if I set list1 sub 2 equal to 10, and then I just do system.out.println list sub 2 sub 2, it's going to print out 10, even though I didn't make any apparent change referring to list2. And that's because when they point to the same memory, then you're just accessing the same memory when you print it out. So if I want to copy arrays for real, then I need to go through all the steps that we went through in that last lecture. I have to declare a new variable, a new array variable. I have to allocate new memory, and then I have to assign all the memory to new values. So if I want to copy list1 into a new array called list2, where the members of list2 are not affected in any way by list1, then what I have to do is I just have to say int bracket list2 is equal to new int list1.length, And that just basically declares me and allocates a space in memory that's equal to the same length as list 1. And then I'll have a for loop, or any loop, whatever, where I assign list 2 sub I equal to list 1 sub I. I take every member of list 2 and I assign it equal to the corresponding member of list 1. And that will create me a new, totally independent array. And this is important because it's easy to have a misunderstanding about how this works. But it's also important because it reminds you that that process of declaration, allocation, and initialization is really critical. If you're not following that declaration, allocation, and initialization process, then it's entirely probable that you're creating a bug by misusing the code. And Java will not complain about code that looks like this. Like, as far as it knows, maybe you really do want to have 2 names for the same array. It happens. Like, there are times when you need that. So this code will compile. It will work just fine. It just won't work the way that you expect it to work. So it's important to understand how exactly you'll copy arrays for real. Another critical thing to understand is how to pass arrays into methods. So when I pass an array into a method, like if I want to declare a method that takes an array as input, because arrays are variables, I can pass them as inputs. I need to make sure that I write the brackets next to the type here. So print list is going to take an array of integers. And the way that I declare this variable taking an array of integers is I say int bracket list. And so inside this method, we could, for example, go over each member of the list and do system.out.println the value of the list. Another thing that's pretty crucial to remember, not pretty crucial, very crucial to remember, is that what you're passing in here is not the array. You're passing in the identifier to the array. When I use this word list, this identifier list, I'm using this thing that points to the space in memory. I'm not using the space in memory itself. So when I have a method that takes an array as input, it's actually taking the pointer to the space in memory as input. And that's very important because when I make changes to that array, those changes will persist. And that should set off alarm bells in your head because you should be like, wait a minute. Didn't Dr. Chen tell us about pass by value and how when you pass data into a method, that changes to that data shouldn't propagate outside of the method because that variable is made a copy of and all that? That's exactly true. So what's happened here when I run print list is that I've made a copy of the pointer to this data. I've done exactly this. So when I run a method that takes an array as input, inside that method, it makes a new variable, let's call it list2, and it points to the same memory that list1 points to. It's not the same identifier, it's a new one. And I can make modifications to this array through this secondary identifier, like here. If I had list sub 0 equal to 4, this would change the memory in that array. And because it would change the memory in that array, that's not protected by call by value. That would change the array. So outside of this code in the main method, say, list sub 0 equal to 4, list sub 0 would be equal to 4 instead of whatever it was equal to before. So this is a really confusing point when it comes to arrays, that arrays have, in a sense, a call by reference behavior. When I pass an array into a method, I'm passing in a reference to that array. And if I perform a modification to that array, then those changes persist, because those are not the things that are being preserved by call by value. In fact, this method makes a copy of this pointer, and the new pointer points to the same memory. So changes inside this method are changes to the same memory, and so those changes persist after the method ends, even if there isn't an output value. Okay, I'd like you guys to think on that topic, and we'll have a lab that exploits that on Friday.